Hello there, my name is Nalani Brown and I am reading Mozart's Starling by Leonda Lynn Haupt. A great book. We are just in the middle of chapter 7, which is Chomsky's Starling. I'm going to pick up where we left off last time. This song is, this is no sweet fluted wood thrush strain. This song is crazy wild. It's gorgeous in a loopy, starling way, and it springs from a little bird with no idea that it has, in the pattern of its song, dropped its shining little body and brain into a turbulent academic debate, one that is both scientific and poetic. Here, biology, language, art, music, consciousness, and yes, human ego mingle, dance, and clash. And that was talking about the Song of a Starling. In the 1950s, a brilliant young linguist at MIT named Noam Chomsky was doing some hard thinking about the nature and uniqueness of the human language. When Chomsky set to work on the topic, all of the social sciences, including the academic discipline of linguistics, were dominated by the tenets of behaviorism, which held that the only proper arena of psychological study for both humans and animals was observable, measurable, and external behavior. Behaviorism had gained ascendance within the sciences in the previous decade due to its ability to quantify human and animal responses in experimental settings, making so-called soft sciences like psychology hard, like mathematics and chemistry. Work on something as murky and unknowable as consciousness was relegated to a scientific backwater, while behaviorist model garnered grants and publication in the best journals. On the language front, behaviorism's progenitor, B.F. Skinner, decreed that children learned words and grammar by being positively reinforced for correct usage. The payoff most often came in the form of a response: eye contact, attention from an adult, or the chocolate cupcake the child had requested using the proper words. Such rewards, for Skinner, were akin to a lab rat getting its Purina Lab Chow pellet after pushing the right button. Chomsky penned a scathing review of Skinner's verbal behavior, like Kant responding to Hume. Woke from his dogmatic slumber to promulgate his own view. He pointed out that children create grammatical sentences following patterns that they have never heard, proving that instruction and reward are insufficient to explain the complexity of human language learning. He came to believe that humans are endowed with a faculty for language, a language organ, as he misleadingly described it, since it cannot be said to be household in a discrete physical structure that contained a universal and immutable set of rules shared by all human languages, no matter how varied these languages appeared on the surface. This is Chomsky's universal grammar, or UG. We generate meaning by using these linguistic rules to combine words, build clauses, and incorporate these clauses into longer sentences. More than this, humans don't make sentences solely by adding to them bit by bit, as if a sentence were a rat growing a longer tail. Instead, we often embed phrases within sentences, a process linguists call recursion. Take the discrete phrase, also a short sentence: Mozart played the violin. We could add it to linear fashion: Mozart played the violin and liked birds. Or we could employ this synadical device of recursion to embed the added information into the original sentence: Mozart, who liked birds, played the violin. And we could go on. Mozart, who liked birds, and in fact composed with a starling perched on his shoulder, played the violin. Perhaps Mozart, who liked birds, and in fact composed with a starling, which had shockingly iridescent feathers perched on his shoulder, played the violin. We could do this forever, limited only by breath and the capacity of memory. Many animals communicate in the linear fashion, we know. Elephants, winter wrens, citizens, all add complexity to their vocalizations by taking a starting motif and adding to it, and then adding some more. But using recursion, humans are able to take meaning through sentences that are more like blossoming peonies growing from within. Chomsky came to believe that the capacity for recursion is not only unique to humans, but the defining characteristic that sets human language apart from all other forms of communication among living beings. Aiming to bolster this theory, Chomsky co-authored a 2002 paper published in Science with Harvard biologist and psychologist Mark Hauser and Tecumseh Fitch, a linguist at the University of St. Andrews in Scotland. In The Faculty of Language, what is it, who has it, and how did it evolve? The three researchers sought to identify the distinguishing features of human language and its development. They scored the literature to compare aspects of human and animal communication, eliminating shared characteristics one by one. Memory, for example, is critical to language because, as Hauser put in an interview, if you couldn't keep in mind several pieces of a sentence, you couldn't understand anything. But memory is not specific to human language. Some animals use memory in communication too. So memory was off the unique to human language list. The researchers continued down their catalog of linguistic features until they were left with just one property that could be said to define human language alone: recursion. To test their theory, Hauser and Fitch created a study to see whether a non-human primate with complex vocal capacity could recognize recursive patterns. They selected the cotton-topped tamarin, a tiny, beautiful New World monkey originating in Colombia. They chose the specifics for its vocal complexity. But if you have seen a cotton-topped tamarin, you might wonder if it wasn't chosen for its cuteness. They are among the Earth's smallest primates, with dark faces surrounded by long manes of white, feathery fur. Their gaze is intense, open, curious. Somehow, the look on their faces seems to say, "Sure, let's study recursion. Have at it. What do you do first?" Hauser and Fitch started by creating a simple artificial language. The words were made up of short sounds pronounced by either men or women, sounds like li and mo. The difference in pitch between the male and female voices made it easy for anyone listening to tell the two groups apart. Then, the scientists combined the sounds into patterns, short sentences really, using two rules. The first rule was very simple. A female sound would always be followed by a male sound. With A and B representing the two sound groups, the simple rule would yield short sentences such as A, B, A, B. The second, more complex rule embedded a female-male sound pair within one of the A-B pairs, with the resulting A, A-B, B. To create a baseline from which to judge the tamarins, the researchers first tested humans, innocent young Harvard undergrads. In fact, to see whether they could learn to recognize both patterns. After listening to 30 sentences, the students were tested on new ones. More than 80% could correctly recognize the recursive sentence patterns. Then Hauser tested the monkeys in the lab. The tamarins listened to recordings of the pattern over and over in the evening and in the morning. The recordings were played for the monkeys again, along with the recording that violated the patterns. When the monkeys recognized the novelty, they would turn toward the speaker and listen intently. According to Hauser, the monkeys noticed when the A-B-A-B pattern was violated, but were not able to pick out violations to the A-A-B-B pattern. Chomsky was not in the least bit surprised. In a disconcerting footnote, several years after the publication of the tamarin study, Hauser's professional colleagues began to question his conclusions and his research ethics. Hauser was a well-known tenured professor at Harvard in 2007 when the school began an internal investigation around possible scientific misconduct. By 2010, the allegations came to public light and a scandal erupted around him. While Hauser had honestly reported that the tamarins could not recognize recursive patterns, the U.S. Department of Health and Human Services Office of Research Integrity found him guilty of several counts of research fraud pertaining to other aspects of the tamarin studies, including fabrication of data and false description of research methods, in the published 2002 paper and in other ongoing work. Hauser ended up resigning from his Harvard post. It might seem that the study served, in the end, only to sharpen the conclusion of linguists like Chomsky. But instead, it led to significant research with another animal that would take the debate much further. When University of California, San Diego, neurophysiologist Timothy Gentner reviewed the tamarin study prior to the Hauser scandal, he immediately thought, my birds could do this. He had studied starlings for years, though he hadn't come to them through an interest in birds or bird watching or ornithological science. He'd come to starlings through gibbons. Gentner found himself unemployed the summer after he finished college, and he took a volunteer job as a decant at the Woodland Park Zoo in Seattle. There, he heard the daily vocalizing of siamongs, large black furred gibbons native to Malaysia, Sumatra, and Thailand. They've been popular primates at the zoo for decades, famous for their singing. The males and females join in ritualized vocal duets, culminating in the male's resonant boom, which can be heard literally a mile away, as those of us who have lived in the vicinity of the zoo can attest. Every day, the inhabitants to all the houses and apartments anywhere near the zoo have their dinner, their sleep, and their romantic tumbles interrupted, or enhanced, by the booming of the siamongs. When Gentner started as a graduate student in psychology at Johns Hopkins, he couldn't get the siamongs out of his head. He wanted to study vocal patterning in animals and perhaps its implications for humans. His advisor suggested he start with the starlings they had in the lab, and Gentner never looked back. He said, "The more I learned about these birds, the more interested I got," he told me. "And they have never ceased to amaze me. They are so adaptive, so clever. Every question I throw at them, they're able to answer, one way or another." He'd researched starlings for years by the time the tamarin study came around. He believed his starlings could recognize the patterns and that the tamarins couldn't. In fact, he didn't think it would even be that hard for them. From his own observations, Gentner knew that both male and female starlings created wonderful, idiosyncratic songs by mingling an array of rattles, chirps, and warbles into uniquely patterned motifs, and that they recognized one another as individuals based on these motifs. Starlings are so turned into sequences. I knew they could do this. It was just a matter of figuring out how to test it. Like Hauser, Gentner created a simple language, but his was based on starlingish sounds, warbles and rattles. He tested 11 birds, and though it sometimes took thousands of trials, 9 of the birds learned to recognize the recursive A, B, B pattern more than 90% of the time. And with a high degree of proficiency, actually discerning the pattern when 3 new pairs of warbles and rattles were embedded between the original pair. The implications were ripe for the picking. Our research is a refutation of the canonical position that makes the human language unique in a singular ability to comprehend these kinds of patterns, Gentner declared. If birds can learn these patterning rules, then their use does not explain the uniqueness of the human language. That is, if a songbird could recognize recursive syntax patterns, then the place of recursion in Chomsky's linguistic views would have to be reconsidered. And the wild rumpus began. Linguists, psychologists, biologists, ornithologists, evangelicals, everyone jumped into the fray, initiated by these tattered little birds. Birds so unwanted by the wider world that Gentner didn't even need a wildlife permit for his research assistants to nab them from trees. The not yet debunked Dr. Hauser's response to Gentner's study was seemingly open-minded. He pointed out that although the starlings could recognize recursive patterns, there was nothing to indicate that they could comprehend meaning in the patterns, which is true. This, of course, would be much harder to study, since humans do not speak Starling, or at least not yet. But he recognized that Gentner's study went far beyond what he was able to show with the tamarins, acknowledged it as an important paper, and claimed that he was inspired to think about ways he might recreate and improve his tamarin study by implementing some of Gentner's methods, perhaps using tamarin rather than human sounds, and giving the monkeys some more tries at listening to shorter sentences. Others, many of them linguists, disagreed strongly with Gentner's conclusion. When interviewed for the New York Times, Jeffrey Pullum, a linguist at the University of California, Santa Cruz, and co-author of the Cambridge Grammar of the English Language, said dismissively, "I'm not buying it." Pullum argued that the sentences involved in both the tamarin and Starling studies were too simple to be of use in detecting cognitive abilities and had to do with grammar. It might have told us something about the abilities of starlings, but it said nothing about the more complex subject of human language. Yet, as Gentner rightly pointed out on a UK radio program, primarily when humans are listening to acoustic patterns, they're perceiving language. Here we are talking about the acoustic recognition of syntactical patterns, a linguistic ability. So if birds and humans can recognize the same patterns, why and how would we draw a line between them? And as a startling place for intellectual discourse, why would we? It seems far more expansive, more respectful of our complex intellect and the potential scientific secrets residing within the bodies and brains and lives of the creatures with whom we share the earth, to respond to such a study with our minds wide open and with a sense of curiosity and adventure. Gentner described to me some of his new research that seeks to answer the question of why starlings might have the need for such pattern recognition capacities. In this work, he's focusing on the second part of the starling song, the one that mixes the starling's individually collected motifs into a long sentence. This section of the song has two components: the variety of motifs and the patterns they occur in. One thing about starlings that is unusual among songbirds is that they are open-ended learners. Most songbirds learn their species-specific calls and songs in the first year, and then they're done. They've successfully learned the language of their species. But starlings continue to learn new sounds, to bring in more sophisticated motifs and sequences throughout their lives. One morning recently, I heard Carmen making an odd new sound. Yeek! Over and over. Hi, honey. I offered one of her familiar phrases, hoping to distract her from this unpleasant noise. But she was not to be deterred. I finally figured out what it was when I was walking past Carmen's aviary into the dining room. She was perfectly mimicking the creak in our old oak floor. Gentner was studying the way starlings of different ages pattern their motifs into sequences, and he discovered that older birds were more predictable than younger birds. The sequences of young birds are mostly random, while the sequences of individual older birds, a 1-year-old versus a 4-year-old, for example, are more predetermined. Say you're listening to a 4-year-old male starling. If you have heard this bird sing before and paid attention to the sequence of his repertoire, then you can predict fairly well what the 8th and 9th and 10th motif will be. Females, it turns out, prefer such predictability. Preference is measured easily enough by observing which males and females choose as mates. Older males make better mates by all agreed upon bird measures. They declare and defend better and bigger territories, claim better nest sites, and, together with females, build better nests. They provide more and better food for their egg-sitting mates and their eventual chicks. And the real measure of the evolutionary biological success, they fledge more young. Thus, life or death decisions for the starling are based on the pattern recognition ability, and the female's leading part in the mate choices feeds Gettner's institution that females are slightly better than males at pattern recognition, something he has not yet been able to measure definitively. But there is a point of diminishing returns. If a song is too predictable, it will become less attractive to the female. There appears to be a balance, a sweet spot, Gettner suggests, between novelty and habituation. Too much novelty is unsettling. Too much habituation is boring. Listening to Gettner talk about all of this, my mind turned to music, to landscape. Enough of both to keep listeners charmed and involved, but still excited and waiting to see what comes next. Just as writers use recursion to believe the monotony of brick-by-brick sentences, musicians use recursion to allow their music to grow from within. The most famous example of recursion in beginning music theory classes is Beethoven's Fifth Symphony, where the familiar da-da-da-dum opening can be traced easily via recurrence and variation throughout the evolution of the movements. Mozart uses musical recursion frequently. Good music, like a successful Starling song, represents a bounded complexity, and a lot of similar basic aesthetics are built into the pattern of language: human music, birdsong, and natural song. I'm thinking of music, I told Dr. Gettner as we talked about the balance of predictability and variation in Starling songs. Yeah, he said, me too, and launched into an esoteric exposition of early versus late Coltrane, during which I completely spaced out. I was pondering Imogen Cooper at the piano, wandering through variations on a theme in Mozart's Piano Concerto No. 17. For the past few months, we have had a quiet visitor in our household. Carmen's Aunt Triley and Uncle Bob, of the Guppy incident, generously loaned us their gnome, Chomsky, the garden gnome statuette. Garden gnome Chomsky was the first sculpture created by Steve Harrington for his small Portland, Oregon company, Just Say Gnome. Their mission, to create and market garden gnomes that will bring a bit of both humor and peace to people's lives and will hopefully also inspire deeper political, environmental, and spiritual awareness and reflection. We have loved having Gnome Noam here on the living room mantle, emanating the aura of combined impishness and wisdom that captures the real Chomsky well. Like any good gnome statue, Garden Noam wears a fine red pointed hat and brown boots. But instead of standing in a ring of mushrooms, he poses next to a table topped with scholarly books, wears glasses, and smiles to himself. I have harbored a fantasy that Carmen would provide an irresistible photo by perching on Garden Noam's little red hat. Dr. Chomsky is famous for refusing to take personal comments on certain issues, and I hope that such an image might inspire him. I would send him the photos along with my linguistic queries, and he would be charmed into responding. Instead, Carmen was deathly afraid of Noam Chomsky and wouldn't go anywhere near him for 3 days. After that, she'd tiptoe over to investigate only after I put dollops of her favorite peanut butter with bits of arugula on his boots. Eventually, she warmed up to him, and as long as I stayed close by, she'd visit Garden Gnome and his glasses, little exploratory gapes. Eventually she warned him, and as long as I stayed close by, she'd visit Garden Gnome and give his little glasses exploratory gapes. Contrary as ever, she refused to sit on his hat for my imaged photo. But Tom managed to get a few nice shots, one of which I did send to Mr. Chomsky, who apparently remained unmoved. I never heard from him, and must join the cadre of writers who are forced to say, Noam Chomsky declined to comment. I love the photo anyway. As it happened, Chomsky's rejection of the suggestion that Gentner's study might invite some rethinking of his own work was immediate, complete, and rather truculent. For Chomsky, all the study showed was Starling memory tricks, rattle counting, and number storage, all of which are rather interesting in a bird. Let's not forget, it has nothing remotely to do with language, probably just short-term memory, Chomsky said in his tense response to the New York Times. Later research by Gentner uses more diversity of patterns and fewer repetitions to counter the possibility that the Starlings are memorizing sounds rather than recognizing patterns. It's a bit of a sore subject for Chomsky. The Starlings are not the first challenge to his theory that recursion is both unique to humans and universal to human language. There's a tiny tribe, the Piraha, pronounced Pida-ha. Pronounced Pida-ha, living at the mouth of the Amazon. There are only about 350 Pida-ha people in 20 or 30 small villages scattered along the Meisi and Marmalos rivers. They speak no outside language, and their own tribal tongue, a confounding mixture of clicks, rattles, lip flicks, air intakes, and bird-like bouts of prosody, have befuddled nearly every linguist to encounter the group, no matter how many years are given to the study. Surface starts on the language would lead to the conclusion that it ought to be simple to learn. There are only 8 consonants. Females use just 7, and 3 vowels. But the need for consonants falls away as the tribal memberships slip into humming, whistling, and a complex rainbow of tones, stresses, and variations of syllabic length. Daniel Everett, a linguist at Bentley University, is the only non-Pida-ha in the world to speak Pida-ha. He originally came to the Pida-ha in the 1970s as an evangelist working for the Summer Institute of Linguistics, or SIL, an international group that trains language specialists to translate the Bible into tongues of the remote tribal groups. The organization doesn't attempt a lot of direct evangelization. Their belief is that once isolated communities get their hands on the Bible in their own language, their conversions will naturally follow. In his decades of working with the Pida-ha, Everett has slowly come to understand that as far as he can discern, they have no collective memory, no original creation mythology, and an insistent denial of complexity regarding numbers and amounts. The Pida-ha recognize only 1, 2, and many, and attempts to teach them to count have failed. There is little grasp of or attention to the past or future, and little concept of the lives people are living when they are not standing there in the flesh, at least not in the way most of us typically understand such things. A person who walks into the woods to go hunting is simply out of experience, says Everett. There's a profound ethos of the present moment, as he calls it. SIL's methodology was a failure. Have you seen this Christ? The Pida-ha people asked Everett. And regarding language, Everett realized fairly early on that the Pida-ha do not use recursion. Later studies by other linguists, including Hauser's research partner Fitch, who flew to the Amazon to do on-the-ground fieldwork, have failed to show that the Pida-ha can recognize recursive patterns. In a new article, Everett stresses that this is not because the Pida-ha lack intelligence. Rather, it is about the connection between their culture and grammar. When he began his graduate studies, Everett was an enthusiastic disciple of Chomskyan linguistics. But the more he learned about the Pida-ha culture and language, the more he fell away from his adherence to the notion of universal grammar. The Pida-ha language, he came to insist, is a severe counterexample to UG. And he stressed his further belief that the Pida-ha are not an isolated case, but that scholars don't know of more exceptions because the entrenched linguistic theory has for so long stifled the impulse to inquire. I think one of the reasons that we haven't found other groups like this Everett said in an interview for The New Yorker, is because we've been told, basically, that it's not possible. In the face of Everett's ongoing research, Chomsky continued to insist that there is no coherent alternative to UG. Outside of linguistics, I follow Chomsky's political activism and commentary with interest. But I cannot mourn universal grammar's decline in the evolving field of modern linguistics. It is increasingly viewed as misguided and outworn at best, and some argue, unintentionally racist at worst. Obviously, Chomsky would never have envisioned such a reading, but if the Pitaha do not recognize recursion, then making an absolute link between recursion and human language could certainly be interpreted as a diminishing of their humanity, and that of any other tribal groups like them. Gettner was not surprised by Chomsky's response to this Starling studies, but he was disappointed that the negative reaction appeared to be based on personal attachment to a particular view rather than on a stringent science. The starting process in Fichthauser and Chomsky's The Faculty of Language paper, the process of elimination that led to researchers suggesting the uniqueness of recursion, presumes a level of knowledge about what is happening in animal consciousness, communication, and vocalization, and pattern recognition that is far beyond the human capacity to fully understand, both in 2002 when the paper was published and today. To presuppose that it is possible for three men to determine exactly what every earthly human group and animal species can or cannot accomplish in their communication is to begin from a place of astonishing hubris, an overstatement of what we do, and surely also an overreach of what we can know. No one is suggesting that human language is not unique and wonderful. As Gettner told me, there will never be a non-human that can model human language. But until we can understand some mechanism that is shared across species, we can't even start to ask what is unique about human language. Yet we find that even among the most liberal intellectuals, there persists a notion that humans and human abilities must somehow remain at the center of the universe. The research on Starling vocalizations and recursive pattern recognition pushes humans a little further off from our self-created pedestal and deeper into the delightful mix of creatures that is the Earth's truest symphony. We are at the edge of a new paradigm shift in the nature of scientific discourse, and we are being led by one of the world's most common, most reviled birds. Darwin believed that all human capacities have an ancestral pathway, which of course makes evolutionary sense. There's no reason to tease out our consciousness in general, or our language in particular, from the wondrous, graced, earthen tangle in which we live. He wrote in The Descent of Man, "The sounds uttered by birds offer in several aspects the nearest analogy to language." That was in 1871. Now, researchers are observing that the pattern of vocal learning in human infants, from babbling to forming words, to developing words into phrases and sentences, mirrors the way young birds learn their songs from adults. Duke University neuroscientist Eric Jarvis recently published an unprecedented study in the journal Science that mapped the genomes of 48 different species of birds. Jarvis had always been interested in avian voices and determined years ago that the way birds learn song patterns seems to parallel the way humans learn from words. He was hoping that his genetic research would expand on the other work showing similar parts of human and avian brains are involved in vocal patterning. The results surprised even him. Jarvis and his co-researchers found 50 overlapping genes in humans and birds that correlate with vocal learning. In birds that were more adept at learning new songs, these genes were more often expressed. Jarvis's conclusions are monumentous. This means that vocal learning in birds and humans are more similar to each other for these genes in song and speech brain areas than other birds and primates are to them. There is at least one way that I am more biologically similar to little Carmen than I am a chimp, a nearest animal relative to Homo sapiens. The basic brain structure that we share with other animals, including birds, is ancient, predating complex communication. This suggests that the commonalities in our modern brains and genes around language are more likely to stem from convergent evolution, where two organisms evolve a similar physical characteristic in parallel, rather than from a close evolutionary relationship. But it's far easier to study birds long-term in a lab than it is to study humans. And Jarvis hopes his and others' new work will shed light on the murky topic of language evolution. We have a fossil record to teach us about physical evolution, but we have no record of humans speaking 70,000 years ago. If birds and humans learn language similarly now, it is possible that our evolutionary pathways to language have run much the same course. While the reaction to Gettner's Starling research for some linguists was negative, the response from the public was enthusiastic. His work was initially published in a scientific journal, but it got picked up by numerous public radio stations and was summarized in popular magazines and newspapers, more than usual for such a paper. This is not so surprising. I believe that it is a natural human tendency to speak and to recognize connection across species boundaries. We are delighted when things we know to be true in our heart and our bones are validated by science. In 2012, an international consortium of prominent scientists signed a document called the Cambridge Declaration of Consciousness, in which they proclaim that animals, from birds to mammals to octopuses, possess consciousness similar to humans. The paper stands at the forefront of what is said to be a new and more enlightened understanding. It is wonderful that animal consciousness is finally being recognized as respectable within high scientific discourse. And I hope that this paper and work like it will help ground a higher standard of ethics for animal treatment in science, agriculture, and entertainment. But I cannot help but think that as an academic declaration, it comes a little bit late. Darwin made the same claim in print 162 years prior. And do most of us really need a scientific document to inform us that the animals we live with are conscious beings? I believe that the human sense of connection with the more than human world is innate and joyous. It is our truest way of being, of dwelling, of relating. It is not new, it's very old. It surfaces in the art and culture of every civilization across place and time, in stories of human-animal relationships that are based on respect, awareness, knowledge, and love. I have no desire to confer on any animal a capacity that it doesn't have. There's no need. Animals have capacities enough. Those who understand, those who do not yet know, those we can never know because they reside in the unique minds of other than human beings. Starlings gather knowledge by their word of their world by gaping. Parrots learn with their tongues. Raccoons with their sensitive pads on the palms of their front paws. Earthworms with their shining skins. We lie in the lap of immense intelligence, wrote Emerson, which makes us receivers of its truth and organs of its activity. And to me, this is the beauty of Gettner's work, and work like this. It reminds us of the creative awareness, at once scientific and poetic, that we stand on a continuum of being, of life, that we are part and parcel, along with every creature that crosses our path, of a fierce and beautiful intelligence. That was the end of chapter 7. Now we're going to go into the interlude. The heart of time for the birds and Mozart. Conductor Michael Tchaikovsky said of Mozart, "I have a theory that he is someone who lived faster than other people. When I think of his life as a film, I always see it as an accelerated movie. I have long held the same notion. By the time of Mozart's final illness and early passing, at age 35, he had witnessed the death of his mother, his father, and 4 of his children, had suffered financial highs and lows, and had experienced the exuberance and anxious depression characteristic of artistic brilliance, all while composing quartets, quintets, symphonies, concertos, masses, dances, quadrilles, several of the finest operas ever written, and a beautiful requiem. the pages laid out across his lap as he died. Lessons, conducting, concerts, concert mastering, court composing. Thousands upon thousands of pages of manuscript written, copied over, published. Thousands of letters sent far and near. Thousands of miles traveled by horse-drawn carriage. Certainly, in terms of the conditions of daily existence, Mozart was no different from the typical Viennese of his time. But in the place of his work, juxtaposed with the hardship of his personal life and the complexity of his artist's mind, he was anything but typical. It is as if the space of a life opened wider in order to contain him. New research confirms something that I have always believed to be possible. For smaller animals, time is perceived in slow motion. In a 2013 study published in Animal Behavior, researchers at Trinity College in Dublin used flashing lights to determine the temporal resolution at which information can be processed by a variety of species. They learned that animals with smaller bodies and higher metabolisms, like houseflies or birds, perceive and process more information in a unit of time than larger animals with slower metabolisms, like elephants or humans. This is why, when we think we are being so sneaky with the rolled up newspaper, the fly gets away most of the time. The sequence of events is unfolding more slowly for the fly. One commentator liked the effect to the bullet time sequence in the film, The Matrix, where Keanu Reeves dodges the bullets coming at him in seeming slow motion while his coattails toss in the wind. To the shooter, the bullets are going at full speed, but in The Matrix, Reeves' character can duck the slow-moving bullets easily. According to this new study, birds live in the Matrix. The implications of this research take us far beyond the notion of dog years. The idea that the lives of shorter-lived animals proceed at a pace that can be measured against a human timescale to find a comparable person age. Instead, we are invited to think far more expansively and relativistically about time. I'm not suggesting to say that a bird with her fleet heart experiences far more in a short life of 3 years than we do in that same period, but that her actual perceived life may be longer than 3 years. The measure is mysterious. The time of the bird's life expands beyond our typical calculation in ways that we cannot understand. At least not yet. It is possible that some people, too, experience this time-space portal, allowing more experience to billow within and around them. That we can tot up the length of certain lives in our usual linear fashion, but that these lives do not fit into this linear measure. That more somehow has been lived. The potential for such experience is woven into our cultural mythologies. In Western Archive, we find fairy, a realm into which one might enter through chance or mishap, or often flute music. Fairy is the place where worlds meet, wild and domestic, dream and reality, language and poetry, human footsteps overlaid upon those of woodland creatures and leaves and mushrooms. It is the land of the imagination and the suspension of time, of the practical interlaced with the magical. Certainly, it is the world of the magic flute. Sometimes when Carmen sits on my shoulder, I close my eyes and listen. She weighs nothing. Were it not for the tiny prick of her toenails, I might not even know she was there. It is all quiet. If all is quiet and my ear is close enough to her warm feathered breast, I can hear her heartbeat. My heart rate, like Mozart's and most humans, is about 80 beats per minute. Carmen's, like stars and most songbirds, is about 450 beats per minute. Larger birds have slower heart rates. Chickens are about 245. Smaller birds have faster ones. Hummingbirds are about 1,000. I put my hand on my heart and my ear to Carmen's breast and feel the pace of our two lives coursing by. The metronome was patented by German inventor Johann Maetzel in 1815. All dedicated students of music are subject to its tyranny, but most composers continue to resist suggesting exact tempos for their work. Instead, the tempos at the top of a musical score are descriptive, suggestive, subjective, and highly relative. Allegretto, fairly brisk but not fast. Allegretto non troppo, fast but not too fast. Lessimo, lentissimo, slower than slow. We know that music can bend and change our perception of time, and myriad studies show how easy it is for humans to fall into a changed relationship with time while listening to skillfully composed music. The UK's Royal Automobile Club even determined that the most dangerous music to listen to while driving, Wagner's Ride of the Valkyries. Evidently, the risk is not that the listener becomes over-involved in the music or that the music itself is too fast, but that the ecstatic nature of the music interrupts drivers' normal sense of speed, causing them to unconsciously drive faster. The late Welsh poet John O'Donoghue believed that music is, perhaps, the art that brings us closest to the eternal because it changes immediately and irreversibly the way we experience time. This, he felt, creates a bridge between the visible world and the invisible, or the imaginal, it is called in the scholarship, where our usual measures make little sense. Mozart lived in this world of music, with ever-changing tempos in his head and a starling on his shoulder. Could it be that his experience of passing of time was unique? That time unfolded for him in a distinctive, idiosyncratic way? I like to imagine that he experienced an interval of his own swift life with the expanded heart time of a bird. That's the end of the interlude and chapter 7. We'll pick up on chapter 8, Birds of a Feather. A lot of scientific research put into the last 2 excerpts of this book, but still a very interesting one. This is Mozart's Starling by Leonda Lynn Hopp, and I am Nalani Brown. Thank you very much for listening, and we will pick up next time.